All right, now that we have our line of regression or our line of best fit right here, we wrote the equation here. What we're going to do is we can use this line that we graphed using technology to find out, according to our regression line or our line of best fit, how many customers will be at the frozen yogurt shop for each temperature. 85 degrees Fahrenheit, 115 degrees Fahrenheit, and 10 degrees Fahrenheit. Now these answers will be the same for everyone because we're all using the same line of best fit. So here's how you can find out these answers. Remember that here are the temperatures in Fahrenheit. And here along the y-axis are the number of customers, okay? So our x's are going to be the degrees down here, our x's, and our y's are going to be the number of customers. So what you can do is you can just put your cursor over the line and click and drag, and you'll be able to see the X and the Y. So if you're looking for 85 degrees Fahrenheit, look at the left number, the X coordinate, and get as close to 85 as you can. There's 85. And the Y number, the Y coordinate, is the number of customers that you'll be serving. If you want to get to 115 degrees, go up to 115 as close as you can get, and then that'll show the the number of customers is your Y coordinate. And then again, if you go down to 10. So you can use technology to your favor by using the graph to get to the different numbers of customers. So another way you can read it is you can go to the degrees here. So this is 50, 60, 70, 80, 85's around here. And then you can go up to the line and you can click and you can get close that way. So you can either drag along the line or you can read the graph. Here's your degrees and then go up to the line and click. So whichever method you want to use. So now that once you fill out this, talk to people in your group and find out from each other how your predictions compare to each other's predictions. And it should, in this case, be the same because we're all using the same exact regression line that we calculated using technology. This isn't the one we estimated, this is the one we calculated. So the way the graphing calculator does this is it does something called a method that's called the least squares method. And so the least squares method is always going to have two things true about it. The line is always going to go through what's called the centroid. And the centroid is the point that is the average of all the x values averaged together and all the y values averaged together. So if you took all the x values and added them up and then divided by how many there were, that would give you the centroid's x value. And then if you took all the y values and added them up and divided by how many there were, that would give you the y value of the centroid. So we'll learn more about that later. But that's the centroid. Another thing the least squares method does is to make the regression line, is it uses this idea that you can see in this diagram. So what you're looking for is the line, if you compare different lines, the one that would have the smallest area of shaded squares. So if you look at this diagram, the points that you can see here and here and here and here, all these points that you can see if you look really closely, those are all the different data points in this data set. And then what happens is, if you were doing this by hand, you would draw a vertical line. So you would draw a vertical line from the point to the line of best fit that you thought was right. So these vertical lines right here, you would draw these vertical lines, and then you would also make a square. So you would draw a square that has that same length. So you would use that same vertical line to draw a square, and then if you were comparing two different regression lines, you would know which was best because it would have the smallest area shaded. So if you compared this line with another line, this one would have the smallest number of shaded boxes. It's kind of confusing at first, but it will make sense over time. So just get the general idea today, and then you will get a deeper understanding later. So the first question on page 137, question 8a, is asking, what do the vertical lines in bold represent? So in that diagram, you can see these bold vertical lines that go from the point to the regression line. If you look at our graph, if we were drawing those points, it would go from the red point up to the purple line, from the red point down to the purple line, right? From the red point up to the purple line. So it's the distance between the points in our data set and our line of best fit. Okay? Now remember, in our diagram, we then made a square that was this distance on all four sides. So if this is the distance between the point and the line, we made a square with four sides of that same length. That's what you're going to be writing about right here in 8b. And the best line, the line of best fit, the absolute best regression line, is going to have the smallest amount of shading. So if you compared two lines, the one with the least number of shaded squares would be the best fit. So you'll write about that here. Now think about the name of this method. It's called the least squares method. There's a reason why it's called that. And in this question right here, where you're comparing Alyssa's vertical distance and Benito's vertical distances, you're going to have to use the squares part of that phrase, because it says the least squares method. So the way this method works is that, so we have Alyssa's line proposal and Benito's proposal, right? So I'll put A for Alyssa and B for Benito. And Alyssa's vertical lines are 2, 2, 2, pretend these are all the same, 2, and 2, 5 2s, right? So all of her points are 2 units from the line. And Benito's are closer, right? His are 1, 1, 1, 1. Well, they're not all closer because one of them is 6 away, right? So these are the distances between Alyssa's points and the line and Benito's points and the line. But the reason it's called least squares is you have to take the distance, and remember we were making squares. So if each of these sides is 2, actually let me use a square tool, okay? If each of these sides is 2, so for each yellow line here for Alyssa, the sides are 2 units by 2 units. So the area of the square that's shaded is 2 times 2, which is 4, right? So Alyssa has 4, but 5 times, right? So 4 plus 4 plus 4 plus 4 plus 4. So 4 times 5 is 20. Now Benito has 4 tiny squares, right? And this square is 1 by 1. So we know the area of that is 1 times 1, because base times height is area of a square or a rectangle. So the area is 1 square. And he's got 1, 2, 3, 4 of those. So he's got 4 1 squares. And then he has 1 square that's pretty huge, actually, compared. So this other square is 6 units. See over here, 6 units. So this other square, let's just say, it looks like that. I'm not really being precise. But this square is 6 by 6. So the area of this square, if you had this shaded in, the area of this square is 6 times 6, which is 36. So if you take the 4 plus the 36, that comes out to a total of 40 shaded squares on Benito's side, and only 20 shaded squares on Alyssa's side. So in this box here, number 9, you're explaining this, explaining who is correct, who has the least square, the least shaded squares, or the best least square regression line, Benito or Alyssa. Then, this is for you to think about, if you look at these numbers, right? Who were you initially expecting to be right when you looked at these numbers? Because if you look at these numbers, if you just added them, it'd be 2, 4, 6, 8, 10. And this would be 1, 2, 3, 4, 10. So they both equal 10 when you add. You might have been expecting them both to be right. Or maybe you expected, because Benito's numbers were mostly lower, that he would be right. But in the end, what was really true? So what can you realize when you think about these numbers and who was actually right, who had the best line? So down here, explain a little bit about what your thoughts are or what you could discover when you looked at this data and then did the calculations of who was actually correct. Happy mathing!